Alright, welcome back everybody. In this video, we're gonna discuss Simulink. Some of you might have already used Simulink before if you had the good fortune of taking that class. I think it's called Modeling and Analysis. If some of you took Modeling and Analysis at USF, Modeling and Analysis, and I believe it was taught by Dr. Campbell. Dr. Campbell, the wonderful person. And it was taught by, it was the vision of Dr. Carlos Smith. So these great men, if you ever had the good fortune of taking this great class, then I feel that the next couple of videos are just going to be, you won't need those. You already know all of that. So if you took modeling analysis, congratulations. If not, then guess what? You're at the right place. All right. So first off, we're going to start off by comparing MATLAB with Simulink. Okay. I'm going to start off by saying that in both of these softwares, Simulink itself is an add-on. It comes with the MATLAB package. So if you have MATLAB 2020, if you have MATLAB 2020 and onwards, then there's a good chance that you already have Simulink on your computer if you've already downloaded MATLAB. Okay. And in both of these programs, your objective is to obtain, basically it's to solve equations numerically. That was the traditional objective, solve equations numerically. Now you also have tools that can solve equations symbolically, but we're not going to discuss that here. The main objective, for us at least, is to solve equations numerically. And by equations, all right, by equations I mean both ODEs, partial differential equations, to some extent using a proper algorithm, and even algebraic equations. Okay, so yeah, both of these softwares can be used to numerically solve ODEs. They have some potential to solve partial differential equations, and they can solve algebraic equations numerically, no problem. Now, okay, the objective is the same, but the method is different. Now we're going to highlight the method. The objective, the why, is the same, but the how is different. In MATLAB, you type code. Okay? I'm stating the obvious. Some of you really enjoy writing code. Some of you absolutely hate writing code. And as a result, you absolutely hate MATLAB. There's no shame in that. Not everybody is going to be great at coding, even though everybody can learn. That's my philosophy. Anyway, in Simulink, we're going to be configuring blocks. And what do I mean by configuring blocks, you might ask? If you've had the good pleasure of working at an internship, and you've had the good pleasure of maybe having Dr. Sunal, then you know how to play with Aspen. And some of you who are from different schools might know how to play with ChemCAD. And I think the other software is Pro, I think, the ones that they use at Chevron. All these softwares, these process simulators, they work on, basically what you do is you select blocks, you input values, and then you click run. That process is called configuring blocks. Nothing fancy at all. So now we've talked about the mechanics, the how of Simulink. Now before we in this video, we're not gonna open Simulink. All right, a bit of a shock. We're just gonna talk about it's going to be a brief overview of what we're going to do next. All right, so once you open Simulink, you would want to solve a dynamic model. A quick quiz. What is a dynamic model? Like, what kind of equations does a dynamic model give? Pause the video, think for a second. All right, I hope you've thought about it, and the answer is differential equations. All right, and in order to solve these differential equations, we're going to need various numerical ODE solvers. All right, we're going to need various numerical ODE solvers. The solvers in MATLAB are still gonna be accessible in Simulink. So you're gonna be using the classic ODE 45 that you've probably been using if you've ever used MATLAB before. I believe another one is ODE 23S, and another one is the one that I've used is ODE 15S. Another question arises that, okay, I have so many options, like when do I use this? When do I use this? Why? What's the difference? And the answers can be found on the MathWorks website, mathworks.com, which I shall link in the description. All these, which differential equation is applicable in which scenario, these answers will be found on the website of the developers themselves, okay? Moving on, we're gonna solve this first order model in the next video. In Simulink, we're gonna go through the entire process. It's gonna be a simple model, a time constant multiplied by the derivative of the output, the accumulation term, plus the output, equal to the gain of the process times the input, x of t input. All right, and if you've ever used a numerical ODE solver, or if you have ever done numerical solutions to differential equations, then you would probably know that a good practice is to have the derivative term on the left hand side and everything else on the right hand side. So our first order model is going to look something like this. Okay, now we're going to look at higher order differential equations in upcoming videos, and just to give you guys a head start, the time constant is going to be 5 seconds. All right, this is just the info of the model. The gain of the process is going to be 3. Now the units, what are the units of the gain? That's my question to you guys. A small quiz, a small homework for you guys. Leave the answers in the comments and let me know. Also, the initial condition. We need one initial condition for y. So when x at t equals 0 is equal to 2, and the initial steady state response, we're going to talk about that in the next video. What does that mean? The initial steady state response, if you go back and assume steady state by getting rid of this term, assuming steady state, we're talking about the initial steady state before we destabilize the system. Then you will come to the conclusion that y is equal to 3 times 5, okay, give me a second, 3 times 2, 6. All right, once again, I want you to work this out by yourself. Work out by assuming initial steady state. Okay, since we're assuming that our system is initially at steady state before being disturbed. All right, just a quick recap from what we've done. We started we gave some recognition to the guys who taught modeling and analysis. Thank you guys once again. MATLAB and Simulink, we discussed the differences. Both achieve the same goal. The methods are slightly different. One, you type code. The other one, you configure blocks. Good, good. All right, we're gonna open Simulink. Then we're gonna solve. Our objective is gonna be to solve the dynamic model, meaning we need the solution to our differential equations. And in order to do that, we have various options. We have all the ODE solvers that are available in MATLAB. Which one to use when? Go to mathworks.com. And yeah, this is the model. This is going to be the our transition into the next video. All right. Thank you for watching.